What's up, everyone? Welcome back. Patrick here. Moving on to the next example in the Unit 1 Advanced Functions test. So we are told that the function f of x is equal to x is its own inverse. And what we have to do is show that there's an infinite amount of linear functions that also have this property where the inverse is going to be the same as the original function. And I touched on this in a video in the lecture videos, if you watch those, but we're going to go through it again here. So let's start off with f of x is equal to x, right? That's its own inverse because we have y is equal to x. Well, if we interchange the x and the y values, well, we get x is equal to y, which is the same as y is equal to x, right? And so the inverse and the original function are basically the same. Okay, graphically this makes sense as well because y is equal to x. Well, it looks like this. And remember, what are we doing with an inverse? We are reflecting it over the line y is equal to x. Well, notice that the line that we're reflecting over, y is equal to x, is the exact same as the original function. And so just reflecting it, the x and the y values are going to interchange to be the same thing. But notice that if we take this parent function y equals x, and let's say that we shift it up, let's say 3 units, right? So we'll have x plus 3. So what I'm going to do is let's erase some stuff. I'm going to erase this original line here that I drew. Okay, perfect. I'm going to keep this dotted line though, right? Because that's the line we're going to be reflecting on. So y equals x plus 3. So if I were to graph this, that would look something like this, right? We're just shifting it up by 3 units, and now it has a b value or a y-intercept of 3. Well, notice that if I take this line and reflect it over the line y is equal to x, we no longer will have that same original line. You could see this algebraically. If I was to interchange the x and the y values, if I isolate for this y value, I bring the 3 over, it'd be x minus 3. Okay, so the inverse of x plus 3 is x minus 3. Okay, which means that the inverse and the original function now are different. Okay, so there's some transformations that when you put them on x and you take the inverse of that, you're no longer going to have the original function. But if you remember from the lecture videos, there is a specific way to have a linear function where its inverse, where its inverse is going to match the original function. And if you remember, that line has to have a slope of -1. And it could be negative x plus anything or minus anything. It really doesn't matter. So let's just put it in general terms and say negative x plus b. But this could be plus 2, plus 3, minus 5, minus 6, could be anything. And notice that this is the original function. Well, if we were to find the inverse, if we interchange the x and the y values, well, if I isolate for the y, I'll bring the y over, it becomes positive y. I'll bring the x over, it becomes negative x. And notice that the inverse and the original function are the same. Okay, and the reason why this is graphically is because notice that a slope of -1 is, let's actually draw this in a different color. It's always going to be perpendicular to the line y is equal to x, right? It's going to be perpendicular to a slope of 1, right? A slope of 1, if you take the negative reciprocal of that, it's going to give us a slope of -1. And so notice that any line we draw that has a slope of -1, it's going to be perpendicular, right, to this line y is equal to x. Okay, no matter where we draw it, it doesn't matter. That's why this b value could be anything. And so notice that if we take 1/2 of the graph and reflect it over the line y is equal to x, we'll end up with the other half. Okay, and same thing vice versa. If we take this half, reflect it over y is equal to x, we'd end up with that half. And so the x and the y values, they're always going to interchange in such a way that we would end up with the original x and y values that we had in the original function, right? Because it's just going to reflect smoothly like that all the time. And so basically, there's an infinite amount of lines in this format, negative x plus b, where the inverse is going to be the same as the original function. So we could have y equals negative x plus 3. We could have y equals negative x plus 50. Y equals negative x minus 100, right? Any b value from negative infinity to positive infinity will work, because it's always going to be perpendicular to this line y is equal to x. So when we reflect one half, we're going to get the other half over the line y is equal to x. And that's pretty much all that could change. You cannot, for example, if you're wondering, stretch this function. So you can't, for example, let's do this in a different color as well. You can't, for example, have like y equals negative 2x plus 3, okay? The inverse of this line is not going to be this line, because negative 2 is a lot more steep of a slope, right? It's going to look something like this, and then when we reflect this over the line y is equal to x, we're not going to end up with that other half, right? It's not going to be a smooth reflection like these green lines are, because they were perpendicular to the line y is equal to x. So if we were to switch this up, if we had like x equals negative 2y, if we were to actually find the inverse of this, what would happen? We'd have what? 2y equals negative x plus 3, divide everything by 2. We'd have y equals negative 1 over 2x plus 3 over 2. And notice that this inverse line is totally different than the original one, like that, right? Versus if we follow the process here, switch the x and the y values, isolate for that new y, you'd see that the inverse is the same as the original function. All right, so there is an infinite amount of lines that where its inverse is the same as the original function, but the lines have to have a slope of -1, and then the b value can be anything you want. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.